All right, good morning and welcome back. This is our final lesson in Chapter 10. Today we will be raising our complex numbers and polar coordinates, and we'll be raising them to some power. So if you think about it, z to the n, this formula works for us, and here's why. Z to the n, say in our case on this first one, find z to the second. So n is 2. We know z to the second means we just take this and multiply by itself. Okay, we take it and multiply by itself. So if we think back to the last lesson we did where we were multiplying, remember we take the two r's at the front, we multiply those together and the cosines and we add them together, whatever theta is, and we add them together for sine. So if we think about it, if we're doing the same thing here, if we're multiplying by itself, then I can take 4 times 4, which is the same as 4 to whatever that power is, so r to the n. I could do pi over 6 plus pi over 6 if we were multiplied by itself, because there'd be pi over 6 for both of them, or I can just take pi over 6 times whatever that n is, which in our case is 2. So either way, we will get the same answer. This involves a lot less work. Now the one thing we do need to watch, it says express the answer in simplest polar form with the argument from 0 less than or equal to theta less than 2 pi. So theta is between 0 and 2 pi. We need to figure out a way to keep theta between 0 and 2 pi. So we might have to manipulate it at the end. So let's start off here. Z to the second. So if we think about it, z to the second will equal r to the n. So the first thing I'm going to do is write down my n. N equals 2. I got that from right here. So r to the second. So 4 to the second goes at the front. Okay, now we're going to have the cosine, and it's 2 times pi over 6, because it's whatever n is times theta, okay? And that same thing then will be there for sine. All right, now let's over here on the side, we're going to figure out what that is. So 2 over 1 times pi over 6. That'll give us 2 pi over 6, which reduces to pi over 3. Now we need to quick check, is pi over 3 in between 0 and 2 pi? And the answer is yes, so we're good. Okay, so now we can go on. 4 squared is 16. So 16 times cosine of pi over 3 plus I sine pi over 3. And we're done. That is all there is to it. So let's do the next one. This next one, a little bit more difficult. It's raised to the 4th power. Okay, so we start off the same. R, in this case, R is square root of 2. So square root of 2 to the 4th. Now, there's a couple ways we can do this. One, go to Desmos, go to the calculator, type in square root of 2 raised to the 4th. The other thing, if we think about it, that's the square root of 2 times the square root of 2 times the square root of 2 times the square root of 2. If we do it 4 times, square root of 2 times square root of 2 we know gives us a 2. Do it again, we get another 2. 2 times 2 is 4. So we'll get 4 out front in just a little bit. Okay. Now it's the cosine of 4 over 1 times 8 pi over 5. And we do the same thing with sine. All right, so now if we think about it over here on the right, we do 4 over 1 times 8 pi over 5. We're going to get 32 pi over 5. And at this point, hopefully you know 32 pi over 5, that does not fall between 0 and 2 pi. If you aren't sure, here's how you can quick check. Whatever your denominator is, if we double it, so 5 times 2 is 10. So we need to get this below 10 pi over 5. Okay? So 10 pi over 5 would reduce to 2 pi, and right now it is above that. So the way we can do that, we just remember we have the circle, the unit circle, and it repeats itself every 2 pi. It's the same thing. So if we subtract 2 pi off one at a time, so in our case here, we're not going to subtract 2 pi, we're going to subtract 10 pi over 5, because that is the same thing as 2 pi. So 32 pi minus 10 pi leaves us then with 22 pi over 5. We'll subtract it again, and that'll leave us with 12 pi over 5. So 12 pi over 5 is still too much. We got to subtract it one more time. And 12 minus 10, that leaves us with 2 pi over 5. And at this point, we are successful. We are within that range. So let's rewrite it. We already found up here to the right, square root of 2 to the 4th was 4. So I can rewrite this as 4. And then I'm going to have the cosine of 2 pi over 5 plus I sine 2 pi over 5. And we're done. All right, we got one final problem left to look at. And in this last one, once again, we're going to do the same thing. So start off the radius to the n. So n equals 8. Okay. Also on that last one, I forgot to write what n was, but we knew n was 4. Okay. So if n is 8 over here, we're going to have square root of 5 raised to the 8th. And if we think about it, square root of 5 raised to the 8th, then cosine, and it's always whatever n is, so 8 over 1 times whatever's theta, so pi, okay, plus I sine, and the same thing, so 8 over 1 times pi. So 8 over 1 times pi will give us 8 pi. I think it's pretty obvious that 8 pi is not between 0 and 2 pi. So we'll subtract 2 pi off. That leaves us with 6 pi. Still not good enough. Subtract 2 more off. That leaves us with 4 pi. Still not good enough. Subtract 2 more off. Leaves us with 2 pi. Now some of us might be tempted to stop there. But do you see how the equal sign is on the 0? Remember on our unit circle, we include the 0. We don't include the 2 pi because that's a repeat of 0. So this is actually not far enough. We're going to have to subtract 2 pi again, which leaves us with a theta of 0. Okay, so 0 will be our theta. Now to find what square root of 5 to the 8th is. First, several options. One, open up this calculator. Whoops. Hit clear, then hit second. Square root of 5 raised to the 8th. We hit enter. We get 625. That's one option. That's probably the quickest. The other option, if we think about it, since it's raised to the 8th, we need pairs of 2 because we know square root of 5 times the square root of 5 leaves us with 5. So for each pair of 2's, so a second pair, or not pair of 2's, each pair of 5's, we get a 5. We are going to have a third 5. And finally, since we need 8 of them total, we will get our fourth 5. At this point now, we have 1, 2, 3, 4. We can do 5 to the 4th. And you'll see that 5 to the 4th gives us that exact same 625. So it's up to you how you think about it. So 625, and then it's cosine, and we found cosine of 0 plus I sine of 0. And that is our final answer. So we're done. So take a look. There is a Delta Math assignment today. It's not that hard. I think I asked you to do 5 of these. If you need help, definitely let me know. This is our last lesson. Tomorrow, Wednesday, we will have a paper study guide to get ready for our test on Thursday. And if you need anything, definitely let me know. Hope you guys have a great day, and I'll see you soon. Bye.